What you're looking at is not a glitch, not a morphing effect, and not a cube tearing itself apart. This is the real motion of a tesseract, a four-dimensional cube projected into our limited three-dimensional world. And today you will see how a tesseract actually moves through a direction your eyes were never designed to perceive. We live in a universe defined by length, width, and height. Everything we have ever observed, every spinning wheel, every orbiting planet, every falling object, happens within these three dimensions. But a tesseract does not belong to our geometric world. It exists naturally in four dimensions containing an extra direction that does not exist anywhere in our physical reality. And when an object rotates through that hidden direction, all we can see is the distorted shadow it leaves behind. Before we can understand how a tesseract moves, we need to understand how rotation works in higher dimensions. In 3D, rotation is simple. A cube can spin left or right, forward or backward, or twist around itself, all using three axes, the x-axis, the y-axis, and the z-axis. But when we step into four dimensions, something extraordinary happens. A fourth axis appears, often labeled W, representing the new direction available only in 4D space. This single axis unlocks three additional planes of rotation: the XW plane, the YW plane, and the ZW plane. Instead of three possible rotations, a tesseract can rotate in 6. Rotation no longer happens around a line, it happens through a plane, a phenomenon we have no direct physical intuition for. A tesseract rotating in 4 dimensions cannot be seen directly. What we see is its projection, the same way a 3D cube casts a 2D shadow on a wall. But while a cube's shadow stretches and bends in ways we understand, a tesseract's 3D shadow behaves in ways that seem impossible. When the tesseract rotates, its shadow in our world shrinks and expands, folds inside itself, stretches beyond its edges, and reconnects in unexpected ways. Yet none of this is happening to the actual object. The tesseract remains perfectly rigid in 4D space. Only its shadow, the part we can observe, is distorted. There are 3 fundamental ways a tesseract can rotate, each producing a distinct visual effect. The first is simple rotation. This is the least strange and behaves somewhat like a normal 3D rotation. The tesseract turns through planes that do not involve the fourth axis, creating the familiar cube inside a cube effect. It bends and warps slightly, but its motion feels recognizable. The second type is double rotation. This is where 4D begins to break our intuition. In 4 dimensions, an object can rotate in 2 independent planes at the same time. One part of the tesseract may rotate in a familiar 3D plane, while another rotates through the 4th dimension simultaneously. These motions do not interfere with each other, they coexist. In our world, this creates the mesmerizing illusion of twisting, folding, and morphing, as if the tesseract were turning into liquid geometry. The third and most profound type of rotation is isoclinic rotation. Pure 4D movement. This has no equivalent in the 3D world. The tesseract rotates equally in 2 perpendicular 4D planes, creating perfect symmetry in 4D space. What we see, however, is a shape that expands and contracts uniformly, with edges sliding outward and inward as if the entire structure is breathing. It feels alive, yet it is simply moving through a direction we cannot perceive. If a real tesseract drifted into our 3D world, we would never see the object itself. we would see only its three-dimensional cross-sections changing from moment to moment as different parts intersect with our space. Just like slicing a loaf of bread produces many different shapes, slicing a tesseract through our world reveals constantly shifting geometry. New cubes appear, old cubes vanish, edges stretch into existence and collapse into single points. The motion seems impossible, not because the tesseract is magical, but because we are witnessing only fragments of a higher dimensional object. Now imagine a tesseract not just rotating but moving forward. As it intersects with a solid wall, the wall appears to fold open and close again. As it enters a room, it begins as a small cube, expands into a cube within a cube, twists into a distorted, impossible form, and collapses back into nothing as it exits. If it passed through a sphere, we would see a sequence of constantly shifting 3D slices, spheres, rings, cubes, shapes that exist only briefly before transforming again. We would never see the tesseract itself, only the sequence of bizarre cross-sections it leaves behind. Many misconceptions surround the tesseract. The first is that the shape changes size. In reality, only the projection changes. The second is that it glows or pulses. The glow is visualization, not physics. The third misconception is that a tesseract is simply a 4D cube. It is more accurate to say it is to the cube what the cube is to the square. A natural extension, not merely a cube with more edges. And finally, some believe the tesseract is a sci-fi invention. In truth, it is one of the most mathematically fundamental shapes in higher dimensional geometry. If you could step inside a tesseract, as a being capable of perceiving 4 dimensions, its structure would feel perfectly natural. You would not see cubes nested inside cubes. You would see 8 interconnected rooms all meeting at right angles in directions that simply do not exist in our world. You could move from one cube to another not by walking around, but by stepping in the 4th direction. The same way a 3D creature can rise above a flat 2D surface. Inside the tesseract, nothing would feel distorted. The geometry would be symmetrical, ordered, and logical. The confusion arises only because we are limited to a lower dimensional slice of a higher dimensional object. Watching a tesseract rotate is more than a mathematical exercise. It is a glimpse into a reality larger than our own. The motion feels alien because it reflects complexity our intuition cannot grasp. In 4D, rotation is not merely turning, it is transformation. A seamless, continuous flow of geometry that obeys rules beyond our everyday experience. And yet, despite our limitations, humans possess the remarkable ability to imagine beyond what we can see. Through mathematics, projection, and simulation, we can construct accurate representations of shapes that should be forever hidden from our senses. Though we may never physically experience 4 spatial dimensions, we can still uncover the rules that govern them. This ability, to reason beyond perception, expands the boundaries of what our minds can reach. You have just witnessed the true motion of a tesseract, not as science fiction, but as a mathematically accurate projection of a real 4D object. But the tesseract is only the beginning. If you want to see what happens when a tesseract is unfolded, or how a 4-dimensional object slices through our world, or what journeys through 5, 7, or even 10 dimensions might look like, continue exploring. The universe is far larger than the space we can touch, and every step into higher dimensions reveals a world more astonishing than the last.